Okay, 55 kilogram. That's the total fuel in the rocket. Burns fuel at a rate of 2.77 kilograms per second for 15.2 seconds. So this is a little bit more puzzling, right? My initial mass is definitely 55.0 kilograms, right? And then it seems like the fuel mass, right, is going to be this much kilograms per second, right? But that's going to be times 15.2 seconds. So let's figure that out. If you burn 2.77 kilograms every second for 15.2 seconds, you get 42.104 kilograms of fuel. Right? So my final mass of fuel, if I subtract 42.104, 55 minus that guy is 12.896. So this is a little bit more difficult. That's my final mass, right? Here's my initial mass. So I had to figure out the amount of fuel that was burned, 2.77 times 15.2, figure out that it was that much fuel, right? Then I had to go that minus this to get the final mass, right? So that was harder, but actually finding what the thrust of it is actually a little bit easier. Let me show you that. Okay, so now to find the thrust, that's our step one, right? It was harder. Step two, this is pretty easy, right? Force times time is mass delta V, right? Here's our exhaust velocity. So we go 1 second. It's that much fuel in 1 second, right? It's 2.77 times 638. Find the force, right? Well, it's just going to be that times that, right? 2.77 times 638 is 1767.26 newtons. That's my force. It doesn't ask for that, but it does. Definitely, this is what we got to find that, right? Okay, so now we're set. Now we can find the initial and final accelerations of the rocket. Our initial is, we've got a 55 kilogram rocket, right? We have a force upward of 1767.26. We have a downward force of what's 55 times 9.81. 539.55. Right, so now we're set. We can go 1767.26 minus 539.55 is 55A. Okay, here we go. This is exciting. This guy minus this guy divided by 55. 22.322, so the acceleration is okay, now we can find the final. So now in the final picture, the rocket looks slightly different. It's only this, right? So it's the 55 minus the fuel it burned, right? So it's going to be 12.896 kilograms, right? There still is a zesty force of 1,767.26 newtons up, but the force down is going to be 12.89 times 9.81. It'll be significantly less, right? Okay, so let's find that number. There it is, that guy. Times 9.81. 126.5. Right, so that's a downward force. So this is upward, that's downward, now we're set, right? 1767.26 minus 126.5 is equal to 12.896 times A. Okay, let's see if I can find that. There we go. Found that guy. That guy minus 126.5. Then divided by 12.896. Here we go. 127.2. Yay.